Greetings and welcome, friends. We were talking about like proofs on the coordinate plane, and doing so would use likely the distance formula, also known as the bane of Mr. Waddy's existence, because I for some reason make mistakes on a simple formula. But nonetheless, this is an interesting problem. It says, what if I wanted to plot an isosceles right triangle with leg length p on a coordinate plane? Now, sure, I could pick all sorts of weird, ways of arranging this. That one didn't work, did it? No. It would have been like here, here, and here. Right, this would be like a very unuseful location to throw a triangle. So I want to set this up in the most conducive way. So if this is the origin, so this would be 0, 0. I could set it up like this. But I think I actually even like making both of the legs move along the axes. So let's say it was here. What would this point be? If it's got if this is going to be one of the legs, and this is a p-lengthed leg, what would the coordinates of this point be? 0, comma p. But yeah, if you're counting the scale that I happen to have, yeah. And then what would this one be? P, comma 0, and let's see. We'll take the 30 seconds to draw the triangle. How do you guys like triangles lately, guys? What? It's all like triangles. This is my favorite. What? Are you guys ready for proven triangles on the test tomorrow? Proven. Man, look at that. This is beautiful. And by labeling those coordinates generically, I now have something that I could work with and prove for all isosceles right triangles with leg length p. Also notice that those are congruent. So if I do a proof, instead of having particular values like 5, I can then talk about all triangles that fit in that case and go from there. All right, let's see. Here it says, write a plan, a p-land for the proof. All right, let's try not to get too crunchy today, though. Yeah. All right, it says the coordinates of vertices OPM and ONM are given. Done it. It says prove triangle OPM and ONM are isosceles triangles. They didn't even ask us to prove these were congruent, right, Jordan? They just wanted to prove these are isosceles. So I'm going to prove like those two sides are congruent and these two sides are congruent. But I have a suspicion that those might even be congruent to each other. So this would be my plan. Use the distance formula to find what side lengths do I want? I want OP. I want PM. Man, why can't I just write the letters today? I want ON, its own, and MN, we'll call it. And show that OP is going to be congruent. How would I show they're congruent? I'd have to show that their measures are equal, and then by def of Kong, I'd know that they're congruent. Show that OP is congruent to PM, and ON is congruent to MN. Right, and then thereby, it's isosceles triangle because it has two congruent legs. So they didn't actually ask us or need us to do the distance formula a bunch. We just had to write a p-land, right? That's my plan. I think that's believable. I believe it. That's pretty good. Let's keep going. All right. Ooh. All right. Find the coordinates of any unlabeled vertices. Yikes. All right. What are our thoughts? UR is equal to K. Do you guys agree? All right. K does not represent 1,000, so 2K sports is not what they're promoting. Yeah, it's just a length. So you're saying that if this is 2K and R appears to be the midpoint by definition of midpoint, Holden, you can throw that out the window. Yep. And R must be the midpoint, and then half of 2K is K. So R's coordinates, its Y coordinate is going to be K. Huh. What do I know anything else about it? What's the x coordinate? That's what I was thinking as well, and then I just realized if this is k units, and it's congruent to this, then this is k units. So it's going to be kk. Let's see, where does u happen to live? What are the coordinates of u? How far over is it? KO. And S appears to be at K comma 2K. T appears to be at, let's see, over, it's K units, so that's 2K. And K units, 2K. 2K. And then O, conveniently, 0, 0. Right. And then it says, find the indicated lengths. Find OT. So O to T. Let's use the distance formula on these values and see what I can simplify, if anything. So I'm going to have the square root of x2 minus x1, right, squared, plus, and actually someone mentioned the Pythagorean theorem, which the distance formula is like a reworking of the Pythagorean theorem, so same idea. And then y2 minus a y1. And notice I'm doing this kind of generically in terms of k, which is very nice. Let's see, so this is going to be 2k all squared plus 2k all squared. You guys perhaps remember that exponents are distributive over multiplication. So that's going to be the same as 4k squared plus 4k squared. Those are like terms. How many k squareds is that? 8k squareds. And radicals are distributive over multiplication, so that's the same as the square root of 8 times the square root of k squared. The square root of 8 can be broken down. Do you guys remember how to reduce radicals? What's the largest perfect square that goes into that? Yeah, so I had to break that into root 4 times, it goes in twice, root 2, right, Ryan? That's what your friend's saying right now? Square root of k squared is k. Actually, it's the absolute value of k. But since k is a positive number here, we're fine. We don't need absolute value. But it is technically the absolute value. So square root of 4 is 2k, and then the rad we'll put at the end. So that's the distance from O to T. OT. Like so. So a little bit of work with variables, but not that bad. All right. I kind of like the work of figuring out where these points are in terms of variable coordinates. Let's see. Last problem. All right. Write a coordinate proof. All right. So let's see if you guys can help me out. So, it says H is the midpoint of da. All right, so that means this is congruent to that by def of midpoint. That means we can actually find the coordinates of H. Is H going to help us? Yeah, they want us to find a segment length in terms of H. So let's use the midpoint formula. So H is going to, actually I don't use equal signs for coordinates, I guess, is going to be the midpoint of AD. So the average of the x's is 0 plus negative 2h over 2. And the average of the y's will be 2k plus 0 over 2. The midpoint formula, by the way, is just the average of the x's over the average of the y's. So this is going to be negative 2k over 2, comma 2k over 2. And so h is going to be the opposite of k, comma k. You guys believe that? Seem reasonable? Seems reasonable to me. Wait a minute. Guys, I completely am wrong here. My x coordinate, this is an h, not a k. What's your question? They wanted us to discover them. Well, just like in any situation, we usually are not given all of the information. And so this is setting you up to see if you can determine that using your own skill set. Let's see, actually this makes sense. If this is negative 2h over, then this would be negative h over. If this is 2k high, then this is going to be just k high. K high. It also said that g is the midpoint. So using similar logic, what do you guys think g is? H comma k. I like it. H comma k. And then they asked, let's see. All right, they gave us the coordinates of triangle DEA. Yeah, so let's find the length of DG. D to G. Let's see if I can do that. So this is going to be some distance formula. Actually, this is a number, so I can use an equal sign. So let's see. I'll do x2 minus x1 squared plus y2 minus y1 squared. H minus a negative 2 is h plus 2, so that's 3h plus k squared. So that's going to be the square root of 9h squared plus k squared. Question, can I rewrite this as this, 3h plus k? Super illegal, actually. Super illegal to do that, but calculus students will make that mistake as well. You cannot distribute an exponent or a radical over addition, so I cannot distribute the square root over both of those components. So that is a no-go. A no-go. No-go. Let's find the value of HEEH. So let's see, x2, I'll call negative h, minus x1. Ryan, you tracking this? Seems like you're distracting a student or something. Let's see, negative h minus 2h is negative 3h's. Still in parentheses. Ryan, if you drop those parentheses, you'll probably make a sign error. Actually, guaranteed. Yeah, don't drop those parentheses. Negative 3h all squared is positive 9h squared plus k squared. So notice if EH and DG are equal to each other by transitivity, then by def of Kong, DG is congruent to There we go. Well, thanks for watching, internet friends. Have a great day. Bye-bye.